Today we are going to talk about the reduction of ketone and aldehyde. So for the reduction of aldehyde and ketones, we are two common reducing agents. The first one would be the lithium aluminum hydride, followed by acid workup. And remember that this lithium aluminum hydride, it should be stored in the dry ether. And the reason is lithium aluminum hydride is very reactive and it will react vigorously with the air. So this will lead to the inefficiency of the reaction. And the second options or second common reducing agent would be sodium borohydride. And this reducing agent is relatively weaker than lithium aluminum hydride, and usually we will put it in the aqueous methanolic or alcoholic solution. So the reason we want to put it in aqueous and methanolic solution, I will talk about it later. So now let's move on to the reaction mechanism. So let's start with the reaction mechanism of lithium aluminum hydride and followed by acid workup. So remember, this is in dry ether. So this is our ketone, say ketone aldehyde. The mechanism will work as the same. So feel free to pause the video and try to figure out the mechanism yourself. So what's going to happen is our lithium aluminum hydride, this is its Lewis structure. So this delta negative hydrogen, because it has a higher electronegativity than aluminium, is going to attack the carbonyl center, which is delta positive, and the electron will go up to the oxygen. And that gives us the structure of a tetrahedral intermediate, so O negative and a H. And remember that this H comes from this. So one hydrogen is added. And so from here, this oxygen, this negative oxygen, is going to grab the AlH3 atom. So AlH3, it is going to use its electron to grab back the AlH3 and forming this structure. AlH3 and this Al is negative again. So from now on, we are going to the second step, which is the acid workup. So this lone pair of the oxygen, or we can say this bond, is going to grab the hydrogen atom to give us our final product, which is the secondary alcohol with the AlH3 and another hydrogen added. So the general equation would be the aldehyde or ketone, whatever, plus two reducing agent. Specifically, two hydrogen ions will be added to our aldehyde and ketone to form either secondary alcohol or primary alcohol. And primary alcohol means when aldehyde is reduced, and when ketone is being reduced, a secondary alcohol would be formed. So you can try the mechanism yourself for the aldehyde. So now let's move on to the other reaction mechanism, specifically sodium borohydride. So usually we'll put it in the aqueous methanolic solution. So now I'm going to use aldehyde as our sample. So feel free to draw the mechanism yourself and pause the video. So what's going to happen is the borohydride, this is its Lewis structure, negative. So this hydrogen again is going to attack the carbonyl center, which is partially positive, and electron goes up to oxygen and forming a tetrahedral intermediate structure. So one hydrogen is added, and from here on, the oxygen will not grab the boron hydride, and that's because it's not reactive enough, right? As I said, that the lithium aluminum hydride is it can be react more vigorously than this reducing agent. So that's why we need the methanolic solution as a proton source to deprotonate our tetrahedral intermediate. So how does it work is the electron from this negative oxygen is going to grab the hydrogen and it will give back the electrons to the oxygen and forming this structure, which is our primary alcohol. So one hydrogen is added. So from here you know that another side product will be formed, and it looks like this. So this is known as the sodium methoxyborohydride. And that's why the aqueous methanolic solution is used. So the general equation would be aldehyde or ketone, when we react with two mole or two equivalent of reducing agent, and remember that these represent the hydrogen ion added to the compound, we will form, if it is aldehyde, we will form a primary alcohol. If it is the ketone, will form a secondary alcohol. So their reaction mechanism is similar, but there are slightly difference between the sodium borohydride and lithium aluminum hydride, and we have explored it and explained it in a detailed manner.